Okay, so here is your section 2.2 warm-up. So go ahead and pause and see if you can work through these with this given conditional statement, write the converse, inverse, and contrapositive, and then decide whether each statement is true or false, like we did yesterday. And then pause this, and then once you're ready to go, then you can unpause. Okay, so let's go ahead and see what we got. So remember, converse is when you take the hypothesis, which in this sentence, the hypothesis is an angle measures 180 degrees, and switch it with the conclusion, which in this statement is it is a straight angle. So you should have something that says if it is a straight angle, then it measures 180 degrees. Now, if you put angle in there somewhere, so if you said if an angle is a straight angle, then it measures 180 degrees, or if it is a straight angle, then an angle measures 180 degrees, either of those is correct, and this is as well. I'll take this as well. Okay, so converse, you just switch the conclusion with the hypothesis. Inverse, you go back to the original, and then we negate both the hypothesis and the conclusion. So it should read something like this: if an angle doesn't measure 180 degrees, then it is not a straight angle. Then the contrapositive is you are going to both switch and then negate. So really the inverse is already negated, so if you switch that, then that's the contrapositive. Or the converse is already switched, so if you take the converse and then negate it, that's the contrapositive. So either one works. So I'm going to take the inverse and just switch that around because it's already negated. So if I say if an angle is not a straight angle, then it doesn't measure 180 degrees. Okay, so next thing we have to do, so that's just writing all the statements, then decide whether each statement is true or false. So remember we talked about when you do this, you have to assume that you have whatever the if or the hypothesis is, and then if this, then you have, assuming that this part's true, you have to see if this part is also going to be true all the time, not just sometimes, but all the time. So here, an angle measures 180 degrees, so you have some angle that measures 180 degrees, then it's a straight angle. So that one should have been true. You should have gotten true. Now remember, yesterday we learned that the conditional statement is always equivalent to which statement? It is always equivalent to the contrapositive. So if this statement is true, the conditional is true, then the contrapositive will also be true. And it's nice to know that, because notice once you start throwing in a bunch of nots and doesn'ts and all that kind of stuff, it can get a little confusing. But the conditional and the converse are a lot easier to decide if they're true or false. And so it's nice to know that the conditional statement is always equivalent to the contrapositive statement. So they both have to be the same, true, true, or false, false. All right, on converse, so if it is a straight angle, so we know we have a straight angle, then it measures 180 degrees. That's also true. And remember that the converse and the inverse are equivalent statements. And so if the converse is true, that means that the inverse is also true. So that means all four statements are true, but we really only just had to check the conditional and the converse. And this was called something when all four statements are true. This was called a definition. And if all four statements are true, and it's called a definition, then we could write what was called a biconditional statement. And the biconditional statement had the if and only if, or IFF for short. Okay? But you didn't have to write that here because they didn't ask you to. Okay? All right, so that's the warm-up. Go ahead and get out your assignment for section 2.2, and I'll go ahead and do some problems that just typically have been question problems in the past. If I don't get to your problem, I apologize, but you can always check Brightspace to see what the correct answer is. But I'll only pick about 2 or 3 problems from the section 2.2 assignment to go over. And again, I'm just going to pick some that were most missed. So go ahead and take that out. You can pause until you're ready, and then I will go over those problems. Okay, so looking at your assignment, you had pages 83 through 84, numbers 7, 9, 12, 13, 19, 26, and 29. So I'll try to do one from each section, and again, I'll try and pick the one that in the past people have had problems with. So let's look at number 9 on the, between 7 and 9, they're in the same section. It says, for the given statements, write the if-then form, the converse, the inverse, and the contrapositive. So the because is like your then part, okay? So on number 9, we would say for the conditional, so this is the conditional, if-then, if 3x plus 10 equals 16, then x equals 2. Okay, so then now using that, let's do the converse. So that's when you switch the hypothesis and conclusion. So if x equals 2, then 3x plus 10 equals 16. The inverse, you go back to the original and negate, and then the negation of equal to is not equal to. So if 3x plus 10 is not equal to 16, then x does not equal to, so you have to negate both. And then the contrapositive is going to be switch and negate. So if x does not equal 2, then 3x plus 10 does not equal 16. Okay. All right, and then on number 7, I won't write it out, but number 7, your conditional could have sounded like if 2 angles are complementary angles, then they add up to 90 degrees. So splitting that up, and then you do the converse and inverse of contrapositive from that. Okay, then you had 12 and 13. So I'll just pick one of those, and I'll pick number 13. On this one, decide whether the statement is true or false. If it's false, provide a counterexample. So remember, counterexamples prove that the statement is false. So then on number 13, supplementary angles are always linear pairs. So remember, linear pairs look like this. Okay, and so we know that linear pairs are always supplementary because we have this straight line, and so from there to there is 180 degrees, and so they would always add up to 180. Okay, but they're saying that all supplementary angles are linear pairs. Okay, that's not true. Because remember, in our notes that we did for supplementary angles in section, what was that? That was section 1.5. You could also have supplementary angles that look like this, where I could say this is 60 degrees. So that's angle A, for instance, and then I could say angle B over here is 120 degrees. Well, these angles are supplementary, but notice they are not adjacent and they don't form a linear pair. So this statement was false, and here's a counterexample. This is an example that shows why it's false. Because not all supplementary angles have to be linear pairs. They can look like this too. And so this is a case where a picture counterexample would probably work best. I mean, you could explain it out where you say, well, if angle A was 60 degrees and angle B was 120 degrees and they were non-adjacent, ... but I wouldn't do all that writing. I would just do a picture counterexample. Okay? Then we had 19. So rewrite the definition as a biconditional statement. So remember, biconditional has the if and only if, so you take out the if then, and you have if and only if in the middle of your statement. So number 19 says an angle with a measure between 90 degrees and 180 degrees is called obtuse. So I would say an angle is obtuse if and only if, and remember we did IFF for short, it measures between 90 degrees and 180. You also could have said an angle measures between 90 degrees and 180 degrees if and only if it's obtuse. So you could just take this piece and this piece and flip-flop them on either side of the if and only if. Because remember, biconditional, that means the conditional and the converse are both true. Actually, all 4 statements are true. And so this is how you could write it with the if and only if in between. Okay. Then we had 26 and 29. It says, write the converse of each true statement for number 26. Tell whether the converse is true. If false, explain why. So on 26, they're saying if x is greater than 4, then x is greater than 0. So that's true. Any number you pick bigger than 4 will also be bigger than 0. Now the converse of that would be if x is greater than 0, then x is greater than 4. Now this is false because if you remember, you have to assume that the if part is true. So I'm picking some number that's greater than 0. So let's say I pick x equals 1. Well, 1 is greater than 0, but 1 is not greater than 4. So you would say x equals 1. So 1 is greater than 0, but 1 is not greater than 4. So then that's why this is false. Okay, and that's my explaining why. That's my explanation. So if I pick x equals 1, so 1 is greater than 0, so it satisfies this, but it does not satisfy the second part. And you could have picked any number, any decimal, but you just couldn't. You could also pick 4, actually. So 4 would be greater than 0, but 4 is not greater than 4, so that would also work. Okay? And then on 29, you had to get a little creative. Write a statement that is true, but whose converse is false. You could actually do something like this. You could kind of copycat this and change the numbers if you wanted to. Or my example, and I don't remember exactly what I might have written on the answer key, but you could say if an angle measures 20 degrees, then it is acute. This is true. But if I did the converse of that, the converse would be if an angle is acute, then it measures 20 degrees. This is false because I could have an acute angle that's 60 degrees. So you just have some acute angle. Not every acute angle is going to measure 20 degrees. So that's why this one is false, but that one was true. So that's an example of what you could have written. Or like I said, you could have just copycatted this type of thing and done that. Okay? All right, so that completes homework. So now take about 5 minutes and go back over your section 2.2 notes before you take the 2.2 mini quiz. So after those 5 minutes, you'll pack up and just have a pencil. And I don't know that you really need a calculator on this quiz. There's not really a whole lot of calculations. It's very much like your assignment where it's vocabulary and being able to write the different statements and that kind of stuff.